Welcome to Cloud on Air, the journey from big data to AI. I'm Cassie Kozarkov, a chief data scientist at Google Cloud, and I'm excited to introduce you to artificial intelligence. My goal today is to demystify the basics for you and show you that building intelligent applications is easier than most people think. So let's get started. Today, AI is everywhere. It powers self-driving cars. It lets us have fluent, real-time conversations with people who don't speak our language. It helps us organize images. For example, take a look at this satellite image. It's pretty hard to tell by eye what's cloud formation and what's snow cover. AI can help with that. It plays our favorite board games with us, and it wins. And it protects our infants from spoiled baby food by helping workers catch defective ingredients early. AI even helps improve the energy efficiency of the data centers required to power it. Exciting stuff. Hey, before we get any further, artificial intelligence, machine learning, what even are these things? Let's bust some jargon. What we think of as AI today is a special kind of machine learning, or ML for short. So let's first look at ML in general. Contrary to popular belief, ML is not a magical box of magic. Instead, it's all about labeling things automatically. In other words, it's one approach to making many small decisions with data. Decisions like, is this email spam? Yes or no? How much should I bid on this item? $1.05 or 88 cents? For each decision, the computer outputs a suggested answer automatically. Now, ML is not the only way to get this done. To see this, let's go back to basics. Making decisions involves taking in information, that is, data, and outputting an answer, or choice, by using a recipe that takes us from one to the other. For decades now, we've been using computers to help us make decisions faster. Everything from figuring out what number to write on our tax return to whether or not an image has a cat in it. Not all of it is machine learning, though. The difference between ML and traditional programming boils down to where that recipe came from. In traditional programming, the recipe is handcrafted by programmers and written as code, an explicit set of instructions for the computer. In machine learning, we let the data work for us, so we don't have to design instructions by hand anymore. Now the programmer's effort goes into producing examples that the machine can learn from, and then applying a machine learning algorithm to generate that recipe automatically. What we'll see later is that some tasks are so complicated that we couldn't possibly handcraft instructions for them, so the only way to get them done is to learn them from data. But first, let's talk about how a computer learns from data. We'll walk through an example task to see what the process for applying ML looks like. In this example, our mission is to build a system that can correctly decide whether I'm going to like a bottle of wine or not. A new bottle of wine that I have never tasted before. So let's try ML. Step 1. Define success. To get started, you're going to need a good imagination. What do you want machine learning to help you with? Don't worry yet about how the machine is going to learn the task. Rather, imagine what you want it to do. How would you know if the output it gives you is correct or not? What's the minimum performance you'd accept for the endeavor to even be worth your time? So what I'm saying is, start by focusing on the outputs. In the case of our wine example, I want my system to correctly say yes or no to a new bottle of wine. Then, I need to think about how good it needs to be. Let's see. I'm going to need it to have at least 80% accuracy for it to feel worth using. Otherwise, I won't bother with it. I'll just ask my friend for a recommendation instead. Great, that's step 1 done. Step 2, wrangle your data. Machine learning is not the kind of magic that makes something out of nothing. There has to be relevant data to learn from, so let's get some. How about using the age of the wine in years and a review score? Since this is a fictional example, I'll make up some data for us to learn from. Let's imagine that I tasted 100 bottles of wine, and I recorded the age, the review score, and whether I liked that bottle. The most important piece of data wrangling is what you will do next. Split your dataset into several pieces before you start using it. We'll see why in a little bit, but for now, let's only look at half of our data, 50 bottles of wine, and save the rest for something important we'll need later. Great, we're ready to do some learning. Let's look at the data that I dreamed up for you. Our inputs, we'll call them features to be a bit more formal, are on the X and Y axes respectively, and the correct answers are plotted as red Y's for yummy and blue ends for not so yummy. Machine learning will use patterns in the data to try to make a recipe that successfully separates the good ones from the bad ones. Why don't you try being my machine for a moment? Your job is to separate the red things from the blue things somehow. See any patterns you could use? How would you do it? If you imagine drawing a line and using it to make decisions, awesome! You've just invented a machine learning algorithm. But hang on. Where would you put that line? Are you sure you picked the best possible place? Where exactly to put your line is what a machine learning algorithm helps you with. That's what they're for. Which brings us to step 3. Train some models. In other words, make some recipes. In order to build solutions, you're going to need some machine learning algorithms. Feel free to just get some off the shelf and use them without worrying about how they work. You'll just pick one and run it. If you're wondering why you can get away with using tools whose math you haven't studied, here's a helpful analogy. Think of algorithms as kitchen appliances. If you're a machine learning researcher, your job is to build algorithms for others to use. You'd need to know exactly how a blender works in order to build a cutting-edge one. But if you're more interested in cooking something delicious, that is, if you're using ML to help your business, then you can use a blender or algorithm that someone else has already packaged up for you. You don't need to know how the wiring works in there. All you have to worry about is what ingredients or data you put in there, and you have to make sure to taste the smoothie that comes out and make sure it tastes good. If it doesn't taste how you want it to, try a different kitchen appliance or different ingredients until you get something delightful. We'll this in the next section. ML algorithms have all these cool names like support vector machines, random forests, neural networks, and so on. When you pick one, you're defining the shape that your recipe is allowed to have. For example, a support vector classifier is only allowed to use a single straight line to separate the good ones from the bad. A decision tree is allowed to use more than one line, but it can only use horizontal and vertical ones, no diagonals. A neural network can put a much more flexible boundary through your data, almost any shape you want. Later today, you'll learn a bunch more about neural networks, also known as deep learning. So let's focus on the 2 simpler algorithms for now. Suppose we decide to use a single line that's allowed to have any slope we like. That's us selecting the support vector classifier algorithm. When we run this algorithm, the machine uses the data to choose where to put the best line. Best in the sense of most effectively separating the good ones from the bad. Boom, there it is. Once it fits that line, what you get as output is what you've wanted all along, the recipe. In machine learning, we'll use the term model to mean recipe. That's all a model is, some instructions for the computer to use to convert data into answers next time. It's ready to use. A new data point, new bottle of wine comes in, and the model outputs red. Delicious. We could have used a different algorithm that would give us a different form of recipe. Let's try a decision tree, which allows multiple vertical and horizontal lines. Run it. Here we go, and there's our recipe. What a beauty. Let's use it to make a decision about this same new bottle of wine. Blue for bad. Interesting. Notice how we got 2 different answers using 2 different models. Same bottle of wine though. So which model should we trust? The right way to pick solutions is not to blindly trust that machine learning is magically awesome. Blind trust is a terrible thing. After all, machine learning is just a way to turn patterns in your data into a recipe. Who knows if they're useful ones? Who knows if it'll work for your task? What do we do? We'll check it's trustworthy in step 4. Test your solution. You should never trust a machine learning model until it has successfully performed on new data. When you're studying for an exam, you should expect to be better at handling examples you've already practiced than brand new examples. To truly test your learning, it's important to try examples you've never seen before. That's the reason we split our data earlier. We kept some untouched examples for test driving our solutions. So how do we do our testing? We simply apply our recipe to this fresh data and we see its performance. If it succeeds with the kind of data it has to handle in real life, then it works. Now, why are there 3 sets? To use an analogy from your school days, Think of the training set as examples that you get to work through in class with the teacher, the validation set as the practice problems you'll try on your own at home, and the test set as the questions on your final exam. Practice at home and go back to class as many times as you like, but you only get to take that final exam once. So good luck. So let's test. Here's our final exam. Let's apply our two models and make some predictions. There they are. Notice how they're different. So which one do we trust? Luckily, I've already tasted these wines, and I know what the right answers should have been. Let's see them. There it is, the truth. Now we can use that to score our performance and see how we did. Any mistakes that our models made are going to be highlighted for you in white. The support vector classifier gave us perfect performance, the decision tree, not so much. Before we commit to using one of these, let's make sure we do some statistical inference to check that the 80% accuracy requirement that we set at the very beginning is met. Based on statistical testing, only the support vector classifier passes our minimum performance requirement. It works on new data. That's the one I'll trust. Now that we've looked at the ML process, let me help you avoid making a mess when it's your turn to use it. Most of the failures and gotchas in applied ML aren't about algorithms. They boil down to forgetting the basics of learning and teaching. So always keep in mind two principles that you already know, specifically. Examples should be relevant, and tests should catch memorization. Let's look at principle number 1. If you want to teach me to speak Japanese, giving me a list of Russian words will not help you much. Even if I can form a mental map or recipe that connects Russian with English, I'm not going to do well at the task you wanted me to do. The same idea applies to ML. Your system can only learn the patterns that you show it. If you put garbage in, you get garbage out. ML practitioners, here's a sentence that is almost worth tattooing on yourself. The world described by your training data is the only world that you can expect to succeed in. If the examples you ask it to learn aren't like the ones you'll get in real life, you'll learn a solution that's great for some other universe. It won't work in this universe, though. And take care to remember that if your business environment changes dramatically, your model won't be relevant unless you retrain it with new relevant data. Principle number 2. If you want to see how well I've learned my Japanese grammar, don't test me on the exact sentences that we practiced together. For all you know, I've just memorized them like a parrot without understanding them. Same goes for ML, so you should always expect performance on your training data to be too good to be true. That's what the term overfitting refers to. The very sound of it, overfitting, fills machine learning practitioners with dread, and rightly so. Overfitting is akin to students memorizing whiteboard examples instead of learning general principles. It could be dangerous to rely on students like that. And there's only one way to catch them doing it. Test them on new examples. That's why it's so important to test your machine learning solutions on relevant, fresh data. Testing is a cornerstone of ML and AI. It keeps you safe and it ensures that what you build works properly and helps your business. Being rigorous and careful when it comes to assessment is the way to ensure that you're using machine learning responsibly. The hardest part of using ML to help your business is not the part involving algorithms. It's deciding what task you want done and thinking about how you'd know if it's being done right. And as long as you're careful to use examples that are relevant for the world you'd like to succeed in, and you're disciplined about checking your solution on fresh data, machine learning is actually pretty easy for you to do. It's okay to try out bad algorithms or ones you don't understand, because if they don't work, you'll catch that when you validate them. When it comes to machine learning, the proof of the pudding is in the eating. If it passes testing, it works. In fact, part of the beauty of machine learning is that you can shift your focus away from the daunting task of trying to understand why a solution works, which was necessary when we had to handcraft our recipes, to carefully ensuring that it does actually work, throwing it away and trying a different algorithm if it doesn't, over and over until you succeed. Everyone is welcome to try it out. You don't need much expertise. So what's the catch? There is one. You need lots of data. In the old days, using large separate data sets for training, validation, and testing was a luxury that few could afford. so machine learning wasn't popular then. Luckily, today's world is generating data like never before. If ML is a rocket engine, data is the fuel. If you have data and the computing power required to crunch it, you don't need a PhD. Come join in the fun. It's an exciting time to be alive. So let's summarize. What is machine learning? It's an approach to making many similar decisions that involves algorithmically finding patterns in your data and using these to create recipes that deal correctly with brand new data. So what's AI then? Let's think about what some classic AI tasks have in common. These are tasks like identifying whether a photo has a cat in it or not, having a conversation, driving a car, or playing games that require intuition. Take a look at this AI learning to play an arcade game. For the first 10 minutes, it plays kind of how I play. Give it 2 hours and it's flawless. And then, after 4 hours, something beautiful happens. This little bundle of math and joy learns strategy. It learns to dig a tunnel. Check out that score. Wow. So what connects these AI tasks? Here's a friendly diagram again. When people do these tasks, we take in complex information through our senses and get the answer as if by magic. You don't even know how you know there's a cat there. You just do. And it doesn't matter how the cat is oriented, you can still tell he's there. Now, it's hard to write a rule that succeeds on every possible cat photo. But you can still find the cat. That's what these tasks have in common. They're all easier for you to actually do than to explain how you did them. If you want to get tasks like these done, programming a computer the traditional way won't work because you can't articulate those instructions. They're too complicated, so we can't expect success using our old approach. AI is the pursuit of success on those tasks, those complex, beautiful tasks that we don't even know how we know the answers for. So in summary, you can think of artificial intelligence as machine learning in pursuit of tasks that are extremely difficult for programmers to handcraft instructions for. Succeeding at AI means unlocking entire classes of tasks that we couldn't possibly solve the traditional way. AI represents a massive leap in human progress. There's so much we can achieve with it. The examples I've shown you are just the beginning. AI is all about complex tasks. And it turns out that if you want your computer to learn complicated instructions, you need more data, more sophisticated algorithms like deep learning, and more computing power. Until fairly recently, no one had the data and the processing power required for success. Because of this, AI used to be in the realm of science fiction. But I'm happy to report to you that the future is here. AI can now perform tasks that we previously thought were impossible. It's already all around you. Just glance down at a smartphone to see some in action. From translation software powered by deep learning, to smart reply for your emails, which helps you write emails faster in your personal style, to automated object detection that helps you organize your photos and retrieve your memories quickly. And oh, so much more. It's easy for you to join in the fun as long as you have the data, the algorithms, and the computing power to pull it all off. And to make sure that you do, Google Cloud has your back. We're putting our vast computing resources at your disposal, along with access to data for classic AI applications, so you don't need to go out there and photograph 1 million cats yourself. And when it comes to algorithms, Google's research teams have designed a powerful suite of tools for you that you can use right out of the box. We've done the math for you so you don't need to worry about it, letting you dive right into everything from classical machine learning methods to state-of-the-art deep learning. Google Cloud is focused on bringing AI capabilities to market as a rich, broad ecosystem to transform your business. From our pre-trained models to our fully managed TensorFlow, we're providing tools so you can harness the power and beauty of your data. We're making it easy for you to create game-changing applications with AI. So how do you get started? The steps required for AI are the same as for machine learning. Think about your task and define success. Prepare your data in the cloud. Build recipes by trying out algorithms until the results look promising. Test your recipe on lots of new data. And then use your solution to transform your business. As you can see, applying AI isn't about arcane math or magical magic. It's practical, and it's a team sport that brings together a diversity of talents to get a project off the ground. no matter what part of the process you're most skilled at. Whether you're a business leader, data scientist, statistician, researcher, programmer, or subject matter expert, there's definitely a place for you to put your best skills to work in creating intelligent solutions. And you don't have to do it alone. We at Google Cloud are here to partner with you to give you the resources and teammates you need to succeed. Today, you're going on a journey with us to discover the best of Google Cloud AI. You'll begin by learning how you can infuse AI into your applications with our machine learning services like Cloud Vision. We have sessions on TensorFlow and Machine Learning Engine to show you how you can build custom models. And lastly, we'll dive into guiding you through the ecosystem of ML accelerators, what's out there, and how to navigate the best hardware choices to power your AI strategy. Thanks for your time.
Welcoming everyone from our AI track. So what you just attended was about how managed cloud services make AI possible for everyone. Did you attend that one, Jay?
Yeah, absolutely. So Cassie did a fantastic job and really built on what Oyvind was talking about earlier, right? So Oyvind talked about sort of the things you need, and Cassie's sort of more focused on the questions you need to ask and how you actually approach those individual problems. And I really loved her use of, these are the three things you need to think about. Your information, essentially your recipe, and then the answers that you get. And what I really love is, is the focus on thinking about what answers you want, which actually makes me think about, you really need to understand what question you want to ask.
Correct.
So you can figure out what the answer is, so you can figure out what information you need, and then you figure out that recipe in between. Sometimes the answer to that recipe is machine learning or AI, and sometimes it's just simple data analytics. So I think it's really important to understand those questions and what you want to ask in order to understand what you want to get out of it.
So what I also loved was how she spoke about how AI is built into right on mobile phones. So whenever we look at probably a smart reply option in Gmail, so that does have AI built in where it kind of gives you these automated responses. So these small product features that Google has in terms of all of our products and services, I think we really have AI in our DNA. What do you say?
Yeah, absolutely right. And we are AI first, and this isn't very much an AI first event. So actually, maybe we should reintroduce ourselves. Hi, my name is Jay Jenkins. I'm the customer engineering lead for Southeast Asia, and I'm based right here in Singapore, where we're coming to you live.
And hi, everyone. I'm Shaista Alia. I'm the customer engineer from India, joining you live from Singapore.
Great. And actually, so going back to Cassie's session, that wine use case was really great because it really simplifies sort of how to think about the problem. And it's easy enough to sort of understand what it is, those two factors, like will I like the wine versus what the age of the wine is. But you can also see how it gets more and more complex as you add thousands of factors, for example, right? What are those lines going to look like, or what are those curves going to look like, or how are we actually going to test whether or not those models are valid? And again, she talks a lot about the approach on how you separate your training data from your validation data and from your test data.
So I think that's really interesting. And I think the next session that we have coming up on the AI track is the crash course on Google Cloud Machine Learning APIs. That's going to be really interesting because what Google has done for these pre-trained APIs is basically offer you the machine learning that we had within our company, within our products. And you have APIs like the Video Intelligence API, we have the Vision API, we have Translate API, which powers Google Translate application. We have the Vision API, which kind of powers Google Photos. So I think that should be a really interesting session to look out for.
Yeah, and Sarah does a great job talking about those APIs and exactly how you might integrate those, or gives you a vision around how you might integrate those with your products. And we'll also have a special guest customer joining us in that session as well. And again, if I were to link those two sessions together, what Cassie said around being able to understand what answers you want, sometimes those answers come from models that already exist, like the pre-built models and APIs that we have on Google Cloud Platform.
That's correct. And I think just for the folks joining us again, welcome to Cloud on Air. And this is, for those of you who've joined us earlier also, they know what the Cloud on Air is all about. So this is the 4th time we're having Cloud on Air across this region. And this time it's a very unique and special event since it is global and we have 3 parallel tracks running, and also we have spread it across different time zones to kind of reach out to a wider audience. So yes, that's I think going to be interesting for everyone.
Right. And I know many of you have been with us before in May, July, and October, so definitely welcome back. Thank you so much for joining us. And it's also important to welcome those people that are new, that are joining us for the very first time. And what's also important is that you provide us feedback. So again, that last button on the side will allow you to provide us feedback on the overall event and let us know what sorts of topics you'd like to cover in future events. And also, don't forget, at the end of each session, there's a form where you can actually evaluate each session and let us know what you thought of that session. You know, was it too high level? Was it too deep? How can we best address your needs in the future?
And also, there's a Q&A button that says Q, and you can go ahead and ask questions which will be answered by Google experts sitting right here in office throughout the event.
Right. I think it's a good point to actually talk about sort of our commitment in the region. So, you know, yes. Earlier you mentioned that we've actually opened up new regions.
That's correct. So we have a data center launched in India, in the Mumbai region, which went live on 1st of November. So it's quite recent. And of course, there's a lot of investment going on in the APAC region. We have also announced something, a new data center coming up in Hong Kong. So we definitely are investing in the region, and because there's a huge market and a huge call-in for this kind of services.
All right, and we've also launched regions in Singapore and
That's
Sydney
correct.
as well. So certainly lots of options for our customers here in the region, so you can place your services in that region and have redundancy within the region as well. Great. So let's talk about industry solutions. So our industry solutions track has just joined us, and they were talking about smarter marketing with Google Cloud.
Yes, and I think just to add on to that, we have the next track coming up for industry solutions is accelerating delivery of healthcare solutions with Google Cloud and AI. Now, Jay, there have been quite a few amazing use cases that I've seen in the healthcare industry all across APAC, be it ANZ or India for that matter. So there have been quite a few use cases, and I think it would be interesting for our audiences to go and watch that session, because that would give them a whole list of use cases and ideas about what Google can do in terms of ML and AI and how we can help the healthcare industry.
Definitely, and actually what I really love about that industry solutions track is it is about how we actually apply AI today into these verticals. So it's extremely, it allows you to sort of understand how you might use those same sorts of solutions in your industry, even if that is not your particular industry.
Interesting. And also, I think with the session that we just ended, what we need to understand is that AI over a period of, if we go ahead and understand it, okay, I think I'll just break there because we are having our big data track audiences just joining us. So the big data audience just finished up with a session of reimagining data warehouse with Google BigQuery, what's new and what's next. So welcome to the audience joining in from big data track.
Great.
And Jay, do you want to introduce the next track that we have for big data?
Sure. So the next track we have for big data is taking a look at data warehousing with BigQuery. So, there's lots of data that's being collected, and we talked previously about complex analytics and moving those to actionable insights. And sometimes those solutions aren't necessarily around machine learning. Sometimes there's easier ways or ways you can use as a managed service in order to get those actionable insights. And moving your data warehousing to a tool like BigQuery allows you to do that. So enjoy the sessions.
We'll see you right here after the tracks, and don't forget to ask as many questions as you have about the sessions. You have the Q&A button right on your left hand side, the right to Jay. So yes, we'll see you again.